to get the values of Ni, we have used three conditions. That conditions, in first condition, we need to draw the sample. We need to draw the sample. Okay. Assume that the cost of drawing sample that was fixed and minimizing the variance. In this second part, we are minimizing the cost and fix the variance. In third part, assuming the sample size is specified and constant and minimize the cost. Okay, so, these two conditions we have seen last class. Now let's discuss the part C. This is the part C. So we have to minimize the variance. We need to minimize the variance for fixed sample size. NH is equal to N. Okay, so we have a fixed sample size. So I have mentioned, whenever I am fixed sample size, that term will be multiplied with your Lagrange's constant, right? So lambda is your Lagrange's constant, get multiplied with lambda with the constant, which is summation Ni into minus N, and this is your variance. So condition is very simple for minimization, that we have already seen, right? That was when we have to minimize the condition. What could be the condition? So we have here two parameter. We have two parameter. What are the parameter? We have one is lambda, one is N, I. So differentiate with respect to lambda, with respect to Ni, then take second derivative of lambda, second derivative with respect to phi, second derivative with respect to Ni. So if I take first derivative with respect to lambda of this particular phi, there is no term of lambda here, it is going to be 0. Similarly, this is 0, lambda is there, so only these terms will come. So we come across summation Ni minus N is equal to 0. So we can come to the point summation Ni is equal to N. When you differentiate this quantity with respect to N, I, what could be that? So I have already mentioned, you don't take summation initially, afterwards you can take summation. So 1 upon derivative is minus 1 upon N square, right? This is 0, this is 0, and there is N, then you have to, because if you take derivative of respect to N, then it comes to the directly N, sorry, lambda. So we have Wi square Si square minus 1 upon N square Ni square plus lambda is equal to 0. So one can get simplify and get the values of N from here, Ni from here. Okay. Now you take summation both the sides. If you take both the summation both the sides, I know this summation of Ni is nothing but N. Why? Because we know this from this condition. So Ni is equal to N. So Ni is equal to N. So one can get the root lambda. So root lambda become just cross multiply, and now you substitute in equation number 1. If I substitute the root lambda value in equation number 1 here, I may get the value of Ni. So root lambda is this quantity, right? Substitute here. So N goes up divided by summation Wi Si. So Ni is equal to N times Wi Si upon summation Wi. So this is the condition for Ni, and even one can further simplify in terms of capital N. So Wi I know, Wi is nothing but Ni upon N. Okay. So one can write in terms of capital Ni also. Means this is with respect to weightage. This is with respect to samples, population size. So these are conditions are same as we have did for the, as we have did for what do you call, two cases. That is same for we are doing for the third cases. Okay. Now we want to prove that this Ni is directly proportional to Ni Si. So this sample size is directly proportional to Ni Si. So how you prove this? Again, this is very simple concept. We know that this condition, that means this condition. So I have written again here. So Ni is equal to K time NiSi. K is a constant. K is a constant. And one can say Ni is directly proportional to NiSi because K is constant. So to remove that constant, I can use directly sign. Now to minimize the variance, when variance will be minimum, so you have to minimize the variance at that point. So whatever the points we are getting here, Ni ka value, either this or you can use this one. You substitute in variance. Okay, so minimum of variance of y bar st nothing but minimum of y bar st. Okay, so what is your minimum of y bar st? Minimum of y bar st is this one, this quantity. So variance of y bar is y bar st we know, which is Ni upon capital N. Okay? So this is the variance of y bar st under Ni is equal to this condition. So this is we have found here. This is we just now found here, right? You substitute, that quantity will be here. If I substitute, this value will be, this Ni value will be here. You need to simplify. You need to simplify. So how we simplify this one? See, what term will be get cancelled with what term? That is the important part. So here, this Wi will get cancelled with this because this is square, this is Si square, right? So 1 S, 1 W will get cancelled with these two. Remaining is summation Wi Si. And here we have summation Wi Si. It goes up, it's become square. It's become square. So we will get it summation Wi Si ka whole square means summation be including summation also it is going to be square. Divide by n minus this quantity will be answer. So this is the variance of you can say minimum variance when you are saying the sample size is the fixed, sample size is a constant value, or one can minimize the cost value. So if we have any questions relating to this, because this is similar to the previous two methods, so if you have any query you can ask. Yes, the only condition which we have to remember phi, and based on phi what will be the minimization condition. Minimization condition को याद रखना है, with respect to lambda लेना है derivative, with respect to ni लेना है. Once you have taken, in second take summation because it is in terms of summation. फर्स्ट वाला सब्स्टिट्यूट करना है, लैम्डा मिल जाएगा. जैसे लैम्डा मिला फिर से यहाँ पे आके सब्स्टिट्यूट करके प्रॉपर एन आई मिल जाएगा. वंस यू गेट एन आई यू कैन शो दैट दिस इज डायरेक्टली प्रोपोर्शनल टू एन आई. ऐसा इट्स वेरी सिंपल. एंड टू गेट द मिनिमम वैल्यू ऑफ वेरिएंस ऑफ आई बार एस टी आपको वेरिएंस में सब्स्टिट्यूट, इतने पार्ट में आपको सब्स्टिट्यूट करना है एन आई का वैल्यू. दैट विल गिव अस द मिनिमम ऑफ वेरिएंस ऑफ आई बार एस टी. बोलो.
Sure, no doubt.
Yes, anyone who having any step difficulty or any doubt? I hope once you start writing the notes, these derivations looks like similar because A, B, C, all three are similar. Only thing is that what we have to need, what we are minimizing, what we are keeping constant. That is the important part. Only that much concept is there. Otherwise, everywhere you are taking respect to lambda with respect to n. With respect to lambda with respect to n. Everywhere we are taking derivatives. Okay. So those concepts are similar and one can easy to perform. Yes, anyone? There are very few students. Why there are only 26 students are there? What happened? इसके पहले lectures नहीं था क्या? इसके पहले lectures था
Sir,
आप लोग का?
sir, lecture नहीं था.
हाँ?
नहीं sir, नहीं. Sir,
नहीं था
lecture
क्या?
नहीं था. 3 o'clock से 4 o'clock sir हमेशा off रहता है.
आज के दिन
नहीं सर, हर दिन ऑफ रहता है, हर दिन 1
हर
घंटा।
दिन?
सर फिजिक्स रहता है, फिजिक्स रहता
यस
है
सर,
वो
यस,
टाइम पे।
फिजिक्स वालों का सर लेक्चर होता है।
हाँ फिर वही मैं
तो
पूछ
सर
रहा हूँ ना
मैथ्स और
फिर।
स्टैट्स का।
नहीं तो फिजिक्स वालों का रहता रहेगा ना, ऑफ नहीं रहता है। किसका तो रहता रहेगा लेकिन अपना नहीं रहता ऐसा। मैथ्स और स्टैट्स
यस
आपका
सर,
कॉम्बिनेशन मैथ स्टैट्स है ना?
यस सर।
हाँ तो मैथ स्टैट्स वाला तो फिजिक्स वाले का फिजिक्स वाले में जाते रहेंगे। इसके लिए वो लेक्चर्स एडजस्ट नहीं हुआ है इसलिए ऑफ दिया रहेगा। कोई बात नहीं ना, एक लेक्चर फ्री मिलता है अपने को, थोड़ा पढ़ सकते हैं हम लोग आपस में। एनीवेज,
यस
so if you have any questions then let me know, otherwise I will proceed. I hope this is the I think last date for the practical number 4 I think. So everybody have submitted their practical. So if not they can submit till today evening or night. Okay, finish it. So this is the I think then we'll move ahead. Then we'll move ahead. What is next one? Now we have to do the comparison between the variances. Okay. So this is the very important question. Okay. So we have seen the comparison in the unit 1, comparison of variance under WR and WOR, and we found that WOR is better than WR, right? So
यस सर।
in this case also, one can see we are comparing the variances under WOR only. WOR only. This is the formula for variance of y bar under SRSWOR. Okay, so we need to compare the variances of a sample mean under SRS with stratified mean under the proportional location and optimum location. तो मेरे पास वेरिएंस है अंडर प्रोपोर्शनल लोकेशन है, अंडर ऑप्टिमम लोकेशन है, और मेरे पास है वेरिएंस हमारा WOR का। ओके, तो तीनों का मुझे कंपैरिजन बताना है, और मुझे what actually I want to know कि which variability is less, which variance having less variability, means which variance is a better. Okay, so for that purpose we need to do the comparison. Okay, let's start. So first what I do, now I have a three variances: variance of y bar, variance y bar st under proportional location, variance of y bar st under optimum location. So what I'll do, I will take two first. W SRS का मैं लूंगा y बार, और प्रोपोर्शनल लोकेशन का मैं y बार, और दोनों को मैं कंपेयर करूँ। फिर से मैं दो कंसिडर करूंगा, मे बी प्रोपोर्शनल और एस आर एस और ऑप्टिमा, और दोनों को फिर से कंपेयर करूंगा, तो दो का रिलेशन मुझे मालूम पड़ जाएगा, तो ऑटोमेटिक मैं थर्ड का रिलेशन बता सकता हूँ। ओके, सो दिस इज द वे वी हैव टू डू द कंपैरिजन. So let us start. So let us consider this formula we are knowing very well. I think if we have gone through the notes, so we have variance of y bar under SRS, we have variance of y bar st under proportional location. Okay, so if you see the difference here, only difference is if the wi is 1, if wi is 1, this formula become your variance of y bar st under WOR. Okay, that much difference is there under proportional location and under SRS. So in order to compare variance of y bar and variance of y bar st, first we attempt to express s square, so this is a capital S square, as a function of si square. बिकॉज अगर मुझे कंपैरिजन करना है तो मुझे जो एस आई स्क्वायर है उसको एक्सप्रेस करना पड़ेगा एस आई के टर्म. सो हाउ वी कैन एक्सप्रेस, नाउ वी नो द फॉर्मूला फॉर एस स्क्वायर. व्हाट इज एस स्क्वायर? एस स्क्वायर इज इक्वल टू समेशन आई रनिंग फ्रॉम 1, दिस इज द फॉर्मूला फॉर एस आई स्क्वायर. If you have remember, you can
यस
understand.
सर।
Yeah, because it is under stratified random sampling, we have seen that. Do the cross multiplication here, this into this, and we need to simplify this summation. We need to simplify this summation. तो कैसे सिंप्लीफाई करेंगे? तो यहाँ पे मैं क्या करता हूँ, आई विल एड एंड सब्ट्रैक्ट y बार i. आई विल एड एंड सब्ट्रैक्ट y बार i. तो y बार I में सब्ट्रैक्ट करूंगा और ऐड करूंगा, ठीक है, और एंड देन minus I will subtract, first minus then plus, and then I will apply a minus b का a plus b का होल स्क्वायर का फॉर्मूला. तो a मेरा a हो गया, ये मेरा b हो गया, तो a स्क्वायर प्लस b स्क्वायर plus 2 time a into b. Can you see here? Third one, next step, a square
Yes.
b square plus 2 time a into b. Now what happened here? I is running from 1 to k and there is a y I bar. I is running from 1 to k. This is nothing but what? This is nothing but the y bar. So if it is y bar and there is already y bar, it's going to be 0. So that's why this quantity will be the 0. So we are left with only the first one and second one. But what you think about the first one, second one? If you see the formula for SI square, what is SI square? SI square is nothing but, because I is running from I, so you have to consider with respect to J. If we have remembered, what is SI square? SI square is nothing but
Equal to 1.
summation over J
Sir,
is running from 1 to Ni Yij minus Y bar I, the whole square, whole thing divided by n minus 1. So I know this quantity
Ni minus 1
becomes,
sir.
sorry,
Hello sir.
sorry,
Ni
Ni
minus
minus
1 है.
huh?
Yes.
Ni minus 1, right, na?
Yes. Yes sir.
Okay, and then we have this quantity. So this quantity become, I can write Si into Ni minus 1. So you can see. So this whole quantity, this much quantity will be replaced by Ni minus Si. Similarly, I will replace here also. Now since here J is running from 1 to Ni is a constant, it's independent of this. So it will multiply simply Ni, and this quantity will be as it is. Now what is next step? You divide throughout by n. Divide throughout by n. This is dividing by n. Okay. So if you are dividing through by n, now there is one understanding part is here. If Ni is large, so Ni minus 1 upon Ni is approximated to 1, and n minus 1 upon n is also approximated to 1. This is very small concept. Okay, this is a very small concept. So if this quantities is equal to 1, so I may say this quantity is going to be what? What about this quantity? So this quantity, can I say it is Ni upon n? I can say it is Ni upon n. Right? So this quantity is 1, because n minus 1 upon n is 1. Correct? And what about this quantity Ni minus n? See, अगर मेरे पास एक 1 lakh रुपीज है, ठीक है, 1 lakh minus 1 divided by 1 lakh, what could be that? It is approximated to 1,
1.
right? अगर मेरा ये मेरा n का हो गया, अगर मैं मेरा स्मॉल n आए, सपोज मैं 100 लेता हूँ, 100 minus 1 upon 100 कितना होगा? Approximated to 1. So this quantity will be turns out to be 1. तो ये लेफ्ट हैंड साइड आपका 1 होगा, लेफ्ट हैंड साइड आपका क्या हो गया? 1 हो गया. और ये जो क्वांटिटी है Ni minus 1 will be approximated to Ni. देखो, Ni minus 1 is approximated to, if you multiply this quantity with 1, it's going to be Ni. So this quantity will be replaced by Ni, and upon n will be as it is into Si square plus a quantity as it is. Now you multiply both the side n minus n. Why we are multiplying this quantity? Because I am interested on my variance of y bar SR. मुझे ये निकालना है, तो मुझे यहाँ पे क्या है, एस स्क्वायर मेरे को मिल गया है और मेरे को यहाँ पे n माइनस स्मॉल एन अपॉन कैपिटल एन माइनस स्मॉल एन चाहिए. तो मैं क्या करूँगा, मैं मल्टीप्लाई कर दूंगा बोथ द साइड्स. तो मल्टीप्लाई बोथ द साइड्स. Once you multiply both sides, this part is nothing but a variance of y bar. And what about this quantity?
Yes.
This quantity
Variance of
is your variance of y bar ST under proportional equation. Only this much quantity is left. Only this much quantity is a positive quantity. Okay. So we need to check whether this quantity is positive or negative. अगर ये quantity मेरा positive हुआ तो ये मेरा right hand side बड़ा हो जाएगा. अगर ये quantity मेरा negative हुआ, ये क्वांटिटी मेरा नेगेटिव हुआ तो ये पार्ट मेरा लेस हो जाएगा. यही कंसेप्ट है इसमें. अगर ये क्वांटिटी मेरा पॉजिटिव हुआ तो वेरिएंस ऑफ y बार मेरा छोटा हो जाएगा. मींस इट विल बी ग्रेटर. इट विल बी बिकॉज दिस इज पॉजिटिव ना, दिस इज पॉजिटिव,
yes.
so that means your this will be greater than, it will be greater, but if it is less then it will be the lesser. So we need to check the whether it is positive or negative. तो कैसे चेक करेंगे? कंसीडर डब्ल्यू आई एंड y bar I minus y. So I have just considered these two things. I know this is weight.
Yes.
This is the weight. तो weight तो हमेशा positive होगा. The weight is always positive. And since this is the square, तो square तो we always know कि square तो कभी negative हो ही नहीं सकता है. कोई भी number है ना, it's going to be square become positive. तो अगर पॉजिटिव नंबर है और पॉजिटिव नंबर है, दोनों आपका पॉजिटिव है, तो मल्टीप्लिकेशन भी तो पॉजिटिव होगा आपका.
Yes.
And if you take summation, summation is also positive. And if you multiply any number, that is number always positive. That means what I can say, this quantity is always positive. So if this quantity is positive, that means it will be directly one can write variance of y bar greater than equal to variance of y bar proportional equation. And hence I can say that variance of y bar proportional equation lesser than equal to variance of y bar. Means either this way or this way, both can be asked, so you can remember whichever way you can feel okay. Yes, I'll scroll it. You go through the steps कहाँ से start हुआ है, कैसे start हुआ है, कैसे execute करना है, that is all important. So s square से start करना है, कैपिटल S स्क्वायर का फॉर्मूला से स्टार्ट करना है, y बार आई सब्ट्रैक्ट और ये करना है, a प्लस b का फॉर्मूला यूज करना है, इसमें एस आई का फॉर्मूला, बिकॉज आई हैव ऑलरेडी मेंशन कि एस स्क्वायर को मुझे एक्सप्रेस करना है एस आई स्क्वायर. अभी क्यों करना है? क्योंकि मेरे पास यहाँ पे एस आई है, इसके लिए मैं एस स्क्वायर को एक्सप्रेस कर रहा हूँ एस आई के फॉर्म में. तो कंफ्यूज नहीं होने का, बिकॉज हमने स्टेप्स लिखा हुआ है, इसीलिए हम लोग एस आई के फॉर्म में उसको एक्सप्रेस कर रहे हैं. फिर डिवाइड बाय एन किया, ये स्टेप इंपॉर्टेंट है, भूलने का नहीं. ये स्टेप भूल जाओगे तो फिर सब भूल जाओगे. फिर इक्वेट किया, सिंप्लीफाई किया थोड़ा सा, मल्टीप्लाई थ्रू आउट किया ये, because I know this is the variance of y bar under SRS, and then this quantity will be weight, positive दिखाना है, and hence it is greater than equal to this. Means under proportional location I can say that the variance under proportional location is a minimum as compared to SRS WR. Because क्यों ऐसा क्यों हो रहा है? Because the data which we are considering, which was heterogeneous, it is split into homogeneous. It is split into homogeneous, right? And whereas in WOR SRS we have the data already homogeneous, but due to some observation your variance can be larger. But इसमें क्या होता है, proportional equations में क्या होता है, हम लोग जो सैंपल लेते हैं, बिकॉज इट इज डायरेक्टली प्रोपोर्शनल टू योर कैपिटल सैंपल साइज, डायरेक्टली प्रोपोर्शनल टू योर कैपिटल सैंपल साइज. तो वो सिनेरियो में क्या होता है कि जो अपना सैंपल होता है वो प्रॉपरली वो स्ट्रेटा में ही आता है. जो स्ट्रेटा हमने बनाया है, and because we have already studied your strata, within it should be homogeneous, between it should be heterogeneous. तो within homogeneous है, मतलब वेरिएबिलिटी का तो ऑप्शन ही नहीं है. What in means within that it will be get minimum value. Okay, so that's why the under proportional location will be always lesser than the variance of y bar under the WR or SRS. Yes. Any question? Any question? Let me know. No question?
No, sir.
Let's proceed. So exactly same way we have to go for. Now we have compared SRS with proportional, and now I'll compare the optimum with the proportional. Okay. So I know the formula for uh, optimum location, which is 1 upon n summation wi si square minus 1 upon n summation wi si square. Right. This formula I am knowing very well. Just a minute. Huh? So you have to just write down the formula for variance of y bar st under optimum location and under proportional location. Proportional location we have just now seen. Optimum location you have to go back and see the formula for optimum location. Okay, and now you take the difference of proportional with optimal. Okay, proportional with optimal. Then what could be the difference? तो अगर मैं डिफरेंस लूंगा 1/n माइनस 1/n, तो ध्यान से देखो तो इसका जो सेकेंड टर्म है, इसका जो सेकेंड टर्म है 1/n wi si, एंड इसका भी सेकेंड टर्म है 1/n wi si square. It is same, and here we have minus sign, here we have minus sign, and we are subtracting. So if you subtract again, it's become a plus. तो ये quantity plus हो जाएगा, तो ये second term cancel हो जाएगा. Then we come, we can once you simplify, we can come to this step 1/n summation wi si square minus this quantity. तो 1/n summation wi si का whole square. Now यहाँ पे एक थोड़ा सा और कंसेप्ट आया है. तो अभी कंसेप्ट क्या है देखो, ये मैंने क्या अज्यूम किया यहाँ पे 1/n we can pull out summation wi si square माइनस ये क्वांटिटी को मैंने क्या ले लिया है s बार स्क्वायर. भी कैसे आया है s बार स्क्वायर, तो स्क्वायर तो ऑलरेडी है, केवल ये क्वांटिटी को मैंने क्या लिया है समेशन wi si को मैंने क्या लिया s बार लिया. अब वो s बार आता कैसे है, उसका सिंप्लीफिकेशन कुछ दिया है क्या लोग ने, हाँ यहाँ पे दिया हुआ है देखो. ठीक है, जस्ट अंडरस्टैंड कि s बार आया है अपना. और देन if you just understand these concepts, one can write wi si minus s bar square का होल स्क्वायर. तो ये कैसे लिखा आप दोनों ने, how we can write this quantity? Can we write this is nothing but this one?
Yes, yes.
How? We need to use a minus b का होल स्क्वायर. तो a माइनस बी का होल स्क्वायर जब अप्लाई करोगे तो क्या होगा एस आई स्क्वायर माइनस 2s bar SI plus S bar square plus S bar square। ठीक है, आई थिंक इसका मैंने एक्सप्लेनेशन दिया है नीचे, तो लेट अस सी द फर्स्ट दैट। तो क्या किया हमने, ये क्वांटिटी को हमने एस बार लिया है और फर्दर इसको एडजस्ट करके हमने ये फॉर्म में लिखा हुआ है, ठीक है। तो देखो, नाउ लेट अस डिफाइन द न्यू टर्म एस बार स्क्वायर। व्हाट इज एस बार स्क्वायर? इट्स अ वेटेड एवरेज ऑफ एस आई, इट्स अ वेटेड एवरेज ऑफ एस आई where wi are considered as their respective weight. So wi is your weight that we are already knowing, and if you take weighted average of SI we'll get the S bar square. So what is the formula? इससे weighted arithmetic mean होता है अपना, वैसे ही सेम आपका जो S bar है वो weighted average of SI है, ठीक है। तो summation wi SI divided by summation of wi, but what we know about summation of wi, it is ni upon n, but summation of ni is nothing but your n, which is going to be 1। तो आपका जो वेट है वो तो 1 हो गया, मतलब इसका जो डिनोमिनेटर है वो तो 1 हो गया, मतलब ये एस बार इज नथिंग बट व्हाट, summation wi SR। so that's why I have written here this quantity become S bar। now go to next step, further consider this statement, to consider this statement मतलब मैंने ये लिया है, ये पार्ट मैंने ले लिया, ठीक है। if I consider this statement, I know W is positive, SI minus S bar is positive. Both are positive. I know this condition. If I know this condition, one can easy to say summation WI SI minus S bar का whole square is positive. Apply A minus B का whole square. SI square minus 2 times SI S bar plus S bar square greater than equal to 0. Get simplify the term. Get multiply. So once you get multiply, ये statement मिल जाएगा. Then what is next step? If you just think here, summation of W is nothing but 1, तो ये 1 हो गया, तो ये क्या हो गया मेरा S bar square मिल गया। Similarly 2 times S bar WI SI as it is है। Now I know again this quantity become S bar, तो 2 times S bar square, ये S bar है, ये भी S bar हो गया, तो S bar square हो गया, तो 2 times S bar square हो गया, यहाँ पे 1 time already है, तो it's become 1 time S। So you can see these expressions I have already here, दिख रहा है।
Yes, sir. Yes.
And further if you divide by n, or I can say I can, ये एक्सप्रेशन फिर से मतलब ये क्वांटिटी इक्वल टू ये क्वांटिटी हो गया ना आपका, तो आई कैन डिवाइड बाय एन हियर, नो प्रॉब्लम, 1 अपॉन एन से डिवाइड कर दो, मेरे को ये क्वांटिटी मिल जाएगा, कौन सा ये वाला क्वांटिटी। एंड वंस यू गेट दिस क्वांटिटी, दैट मींस दिस क्वांटिटी इज पॉजिटिव, मतलब ये क्वांटिटी मेरा क्या हो गया, पॉजिटिव हो गया। ये क्वांटिटी पॉजिटिव मतलब क्या हो गया, ये क्वांटिटी पॉजिटिव हो गया। अगर राइट हैंड साइड पॉजिटिव हो गया आपका, तो लेफ्ट हैंड साइड ही पॉजिटिव हो जाएगा। लेफ्ट हैंड साइड पॉजिटिव मतलब क्या होने का है, मतलब वेरिएंस फॉर प्रोपोर्शनल लोकेशन विल बी ग्रेटर देन इक्वल टू ऑप्टिमम लोकेशन, मतलब ऑप्टिमम लोकेशन विल बी हैविंग लेसर वेरिएंस, मतलब ऑप्टिमम विल बी लेसर देन इक्वल टू प्रोपोर्शनल। So if
Yes.
optimum is lesser than equal to proportional, and I know proportional is lesser than equal to SRS, so I can conclude that optimum is lesser than proportional, and that is lesser than SRS W. So this is the entire concept, I can say, in terms of your comparison between optimum, proportional, and SRS W. So you just go through. If you have any questions, then we can discuss. So you can download these notes is there in GC. Just go through, write it down once again in your notes. Okay. So once you write in practice for this, you can able to write it entire derivations. So here you found that your optimum location is the best.
Yes,
Out
yes.
of out of these three, optimum is best among all, and then next best is proportional, and then SRS will be the least one. But if I compare with WR and WOR, then WOR will be better.
Yes, yes.
Yes, anyone? Any difficulty? Any question?
No, sir.
Yes, Janvi, any question? You're there, Janvi? Pawan Dikshit. Pawan Dikshit is there? Pawan Dikshit is there? Roshan Gupta. Where are you all? So if you have any question, then let me know.
हेलो सर।
Yes, beta, बोलिए.
सर वो प्रैक्टिकल सबमिशन के लिए वो लिंक ओपन नहीं हो रहा है।
अरे बेटा कैसा नहीं हो रहा है, सबका तो आ गया है लिंक.
जस्ट ट्राई किया था।
मेजॉरिटी लोग का तो आ गया है अभी.
अभी नहीं हो रहा है सर, अभी
भी
जस्ट
नहीं हो
ट्राई
रहा.
किया।
फिर से ट्राई करो जरा वापस से और मुझे दिखाओ क्यों नहीं हो रहा है.
ओके।
क्योंकि अभी तो 4 लोग का रिस्पॉन्स आया. So I have already prepared some data for our practical. We need to just verify. So this data is like, so you can able to see this data. I think this is submitted. Let me see the last date. Just a minute. Huh? Whether your name is there or not. So this is the all practicals data, and I think this is till last date. Till 9 on 9 we have submitted. This is Sunil is there. So if Sunil is there, they can see their name. The name which is highlighted, they are not given on proper time. So they can see whether their name is there or not. So I have listed. It is in order. Okay. Maybe the last which I have pasted, maybe that is not in order. Otherwise, all names are in order. So let me know if you have submitted, but your name is not there.
Hello, sir.